So whenever we want to apply a twisting force to something, that means we want to apply a torque. So torque is literally a spinning force. So let's do that with a SOP solver. So drop down a SOP solver. We'll connect it to the rigid body solver. We'll put it in this second input here that says pre-solve. And we'll just call it something like apply force, or applied torque, I should say. Apply with a Y. Cool. So jump in there, and there it is. There's our sim being imported from our dot geometry. Now we only want to do this to the one piece of geometry. So I'm going to say, click that. Make sure you're in the path selection mode. Click on this door, the main chunk of the door. Not this door here. We just want to click it on this piece here. So there you go. It's that door outside metal A thing. There we go. And so we're just going to say, hey, you know what? When you run this, we're going to add this torque attribute, an attribute that's recognized by the bullet solver. And what we're going to set it to is some kind of value that we arbitrarily input here. CHV is going to mean give us an input that is of the vector type. And it's called torque. So you can see it named it for us already. So we can put something in here like 1, and I'm putting it in the y-axis because I want it to spin on the y-axis, which is the up and down axis, which is the hinge axis. So I'll make an output here. And now every frame that this runs, which is every frame right now, it will do that. But we don't really see anything happening. Now rest assured it is happening. It's just that these pieces have a mass. And if we want to see what that mass is, go to any frame after the first one. And we should be able to see, or actually I guess we're in the simulation here. So if we expand out the object and click geometry, you'll see, and I'm just going to say hide everything except for the mass. There it is. So these things have a substantial amount of mass, especially these big pieces. So a force of 1 isn't necessarily going to do anything. So let's jump into the safe sim over here as well. And let's just have this here so I can change it. So let's go in orders of 10. So it looks like 10's still not doing anything. Let's go up 100. Oh, that's doing something. It's dancing is what it's doing. So that's kind of fun. It's still not as explosive a door open as I like. So I'm just going to say like, yeah, that's pretty fast. So it's going crazy, but that's not wrong. It's just, it knows not to collide with itself, so it's not. And it's allowed to basically rotate anywhere around this point, so it's doing that too. So that means, what do we have to do now? Well, we need to figure out this cone twist constraint so that it makes more sense. So I'm going to change the color of the glue, make it blue or something, so that we can see this red one easier. So here we are. So we got this. If I were to put this down to 0, so 180 and 180 basically means it can go any direction, because with the cone like this, even though it just looks like it's one cone on one side, you could basically imagine it being on both sides, because either both sides, both pieces of geometry are hooked at the point here, and it's hard to imagine, but if you could, both can basically move this way. So you can essentially multiply any of these numbers times 2. Hopefully that will become clear as we go along. But when I say 180, we're effectively saying 360. So anyway, just trust me on that for a moment, because I know it's weird. So if I move this to 0, bing, you can see I have just a circle now. So now this thing is allowed to only move in a circle, which is it's doing. It only rotates on the circle, and the force is essentially being negated because it's not allowed to move in the y direction at all. So not much is happening. It's actually, it's kind of moving a little bit. It's crawling, but for all intents and purposes, it's not moving. So that's not the plane that we care about. This is the plane that we want, like this. If we were only to do half, and we had this kind of cool, weird, conically 3D shape, it will be somewhat more restrained than it was, but still not right. We want it to be completely restricted to this plane. Like that. Now what else we want to do? We want to, now we can come back to this actually, and see this? Now it looks like a Pac-Man kind of guy. Now, we want the door to just open 180 degrees. We want to start here and open to here, like that. So that's 180 degrees, which means we need to put, again, 90 in this. So we can see we've got it, it's got a 90 degree thing here, which isn't quite what we want. We want this to be the full 180 to be in the front. But let's look at this anyway. That's something, and that's not bad. It's not spinning forever anymore. It's opening along its hinge. We can see that the hinge looks cool. It's working. But it's only getting to here. Technically, it's allowed to spin 90 degrees back into here also. If we were to reverse this, you'll see that it is so. Now we definitely don't want to do that. So what we essentially want to do is rotate this whole 180 degree field 90 degrees this way. So let's take a closer look at these values down here now. So the goal up, so we have these things, these goals and these constraints. The goals essentially are what the field of motion that it's allowed to do in general. And the constrained is where is it now within the field that it's allowed to do. So in our case, we want it to do 180 degrees of motion, but it's already starting all the way at one side of that 180 degrees, as opposed to how it's set up right now, where as we saw, it can go 90 this way, or it could go 90 back the other way. It's starting in the middle. So that's why we have constrained. So watch this. So the goal up is 1, and the constrained up is 1. We don't need to change that. That's fine, because the up is the y up here. That's fine. Now the goal twist axis is interesting to us. Currently, it's saying the goal twist axis is 1, 0, 0, which is, of course, x being 1. And see how the x is down here? 1 is pointing off in the positive direction, which is why it's centered along that axis. The constrained twist axis is also 1, 0, 0, pointing in that direction. That's why we're starting in the middle, because the place that we're locked is the same as the middle, which is essentially what the goal twist is. So what does all that mean for us? Well, at the end of the day, the door is aligned with 1, 0, 0. So that's fine. It's the goal, though, the range of motion that we want it to be allowed to be in should be centered along this axis, which is the z-axis. We want this whole half a circle to be rotated this way so that it's aligned along this z. So all that is to say, this z is 0, 0, 1. So we just need to change this to 0, 0, 1. And you can see now the whole 180 degree thing is centered on this goal twist. The goal up is the same. So the constrained now is different than the goal one. The constrained twist, rather, is still x, is 1, but the goal now is this. So long story short, press play, there it is. Now it's still applying this torque every frame, which we don't need to do. But suffice to say, or suffice to say, as I'm told, this is right now. So now we've got a door that we can control, is connected in a nice little rigged setup. Everything is coming together nicely.